Hello, everybody. My name is Laurent Völkel, and today I just want to present something about e-mobility, especially for the reliability of the electronic component. And I'm field application engineer and business development manager for energy harvesting application. And I'm working with Wurth over 20 years, and I will make this presentation, which was made from Alexander Gerfer, our CTO. So I start with a small, I would say, shocking you, maybe. Just try to imagine you're walking in the mountains and it's middle of the night and it's very dark and foggy and your battery is empty from your lighter and you know that there's a edge of the cliff, but you don't know where there is and how you will feel if you imagine that situation for yourself. Just try to close your eyes and imagine you're in a totally dark night and you will hiking somewhere and you will know that some place there is very dangerous and you will maybe fall or maybe not. How you feel in this position? So actually, this is exactly what is happening when you're talking about electronic components, when you talk about e-mobility. Right now, we have a kind of reliability test, which is just give you a importance about and information how this component will work with a predestinated environment, and that doesn't give you any warranty or doesn't give you any information about really how this component will perform above his entire lifetime. So when you talk about electric car usage, and you take just the passenger car, which statistically, if you're looking at the statistic, we are using our cars something like 1.5 hour per day. Also on this statistic, the guys tell we will use this car at least 15 years. So the operation of the kind of components in this case will be roughly something 8,000 hours. Now, if we still use alone our car and only just for private use, it will not change this time of the usage of the car and also of the components. But you can imagine how it will be tomorrow if you talk about shared use, car sharing. In this case, it is the user's 22.5 hours per day, and in 15 years means 121,000 hours. That's a big difference to the standard private use. Now, if you take a closer look about the electric car, how the electric car is manufactured and what is the main components in this car, okay, we don't talk about the wheels and the steering and a special option, but electric car have an onboard charger. The onboard charger charge some batteries. The batteries power through the inverter the electric motor. So this is actually a very easy, simplified explanation of electrical car. Now, if we have the onboard charger will be charged with the alternative current from the mains. So we take the lines and we charge with a standard charging station, which make from AC current, first DC current, because the battery must be charged DC, and charge the batteries. Well, that's still okay. There's no issue on none yet, but we have vehicles which are in two grids. It means you can use the same battery from your car while it's connected to the grid, also to discharge him and supply the legs, the gaps in the grid. So it means it will discharge the inverter himself. It will make from DC current AC current, and it will put back into the grid. So in this case, we have now another situation, not just a simple usage of the car. So in the tomorrow shared use, we will prefer to use only just charging to be not a backup for the grid. In a private use, yeah, it looks a little bit different because every time when you park the car in a station, some mall or shopping center, or when you come home to your garage, you will plug it in because you want to have a 100% full charge battery to be ready for the next trip. So automatically your private use time, it will change again to 22.5 hour per day because your car battery, it will be charged and discharged. Now, let me take a look on the battery management system. If you look on the battery management system, we have this DC charge, which is uh, charging your batteries and then supply the DC current from the battery to the inverters. And then we have the discharge during the regenerative braking, because the electrical car, to be efficient enough, it will use the braking time and to recover this immersion energy and produce DC current from the electrical motor. Now it's a generator, and recharge the batteries. So we will have this two grid by the regenerative braking at all. So even we are not thinking about to use our car like a backup for the grid, we will have this kind of two grid anyhow. Now, if you take a look again about the shared use, using 24 hours a day, it will be 100,000 hours. And even if the private use, if you look on that, it will be 24 hours per day, 100,000 hours or more at all. So that's a little bit different to the 8,000 hour. How about now of the component lifetimes? Well, the component lifetime in this case, it will be a little bit difficult because if you take the best capacitor, which give you a lifetime in a standard average usage condition, it will be something like 10,000 hours. It means we will have a lack of 90,000 hours at all, just using electrolytic capacitor, which it must be a component into the car. So how about the next different components? You think, okay, we can use a multi-layer ceramic capacitors, which can handle some more lifetime in this case, but power inductors, transformers at all, we will need that. We qualify that in vibration and voltage and temperature, but how these components will work entire lifetime, 100,000 hours? And this is not all, because we have active components into the car. We have electromechanics component. We have even the PCBs, the assemblies. All these components is parts of the electrical car. It's ACQ 100 or ACQ 200 the right answer for that? I think not. I can tell you in Germany we have a association of electronic manufacturers, and they try to make a validation. They make a working group, and they try to make a robustness validation, and to find out some failures, to find out some mechanisms, some profile, to find out what can we do. So important is that the ACQ, it's very critical consideration. It is not enough. So we need to make a new robustness and validation plan. So this is what this Electronic Manufacturer Association tried to do with the validation group. At Würth Elektronik, of course, we try to do everything what is in our possibility to increase the lifetime and to do this deliver these data to have a good process. And in case of validation of this robustness, we have to think about thermal, mechanical vibration, humidity, all this electromagnetical. Then in function loads, like if you change very frequently the temperature, you have a more cycling of the temperature. You have different condition like stop and go. You have high speed, of course. we drive high speed in Germany, you will use the high speed of the electrical car as well. Even in US, if you're using just 65 miles, it's still enough. It's still high speed in consideration if you drive in the city or you drive out of the city on the highway. Yeah, all these requirements, it will be already possible to give your information about what will be expected to the components. So now we have a different stress source for the electronic components. The highest stress level, which is given, it is the temperature, temperature cycling is special. Then the next is the vibration shock testing, and humidity and moisture is also affecting quite a lot, and that's the reason why we're taking care also about these issues. And then we have some contamination and dust, which can also affect components, which is not 100% in the enclosure or some case. So what we did find out is very important for components is to try to manufacture new components which can withstand something like high peak currents. And when you have an input capacitor like in a power supply and you apply the battery, you connect the battery, you will have automatically a high peak current until the capacity is charged. And these components must be robust. You can see here some picture what happened to the component, the standard component, which have been not designed for that kind of inrush current. These are multi-layer chip bit ferrites, and you can see here some very nice pictures, and the silver layer, it's almost disintegrating inside of this component and making smoke and flames, and this is something which you don't want to see on your car or on your device. What we did make this multi-layer power suppression bits, which they have a pulse definition, so we can exactly tell you how much maximum pulse current it can withstand, and also the pulse length. According to the different components, we can define what is the maximum pulse length and what is the maximum current which you can pulse. And also, according to the maximum current, we can give you information how many times this component can withstand the pulse. So we think that if the component withstand more like 100,000 pulses, that's more like enough, and you will not have this problem that a component will be destroyed during the operation time. The standard rated current will be not a problem. The inrush current will be the problem. So what we did done very special. Actually, it's a new development, a special inner layer. You can see the inner layer. It's very, very intensive thick, much different to the standard layers, and also the distance on the layers is different and much more stronger. So we did make here our special layer construction. I cannot tell too much about exactly how we do it because it's a company secret, but you can see on these pictures, this is a big difference if you take a standard multi-layer chip bit ferrites, where the layer is not that thick and not that wide and not the same distance and so on. So this is a component which is high capability of the pulses. Additional, we have a very stable process with a very, very narrow yield rate, so we don't have too much failure in our processing and during the component manufacturing. So we qualify, of course, ACQ 200, but not only just ACQ 200, we go above this qualification and we do some additional internal process, and we can say we have a different level, like up to grade 0, so which is 150 degree. Normal grade 3, it's something very, I would say, a weak component, and a grade 1 is a standard, but a grade 0 is something which is mostly the best component which can be achieved in the manufacturing. We use different laboratories, and we invest a lot of millions euros for buying different machinery, impedance analyzer, and all this network analyzer, which is testing 100% during the manufacturing the components. And yeah, we make a big investment for achieving a high quality level. Time to accelerate, it means that the factor 10 to 15, it will be a requirement to the component definitely in the next future. We will have to concern about the temperatures as well, because when you are using batteries, you have a different temperature level, whatever you are charging or discharging or just operating the inverter for the electrical car. And there are some started initiatives like RES 2.0, a car project, which is again, it's a more like between a German car manufacturer and assemblies who are doing component delivery to the car industrial. So there are already some initiatives already started. Also, the German Electronic Component Association. Definitely, we are covering a lot of experience during our sponsoring of Formula E. This is the electrical car Formula One in worldwide, which is we are sponsoring the Audi team, and we are trying to get more and more information and collecting a good knowledge how to do components with higher reliability, definitely. So the time is now to do components with more lifetime and with higher quality. Hope you enjoy it. If you have any question, please ask us by email or contact our salespeople on the field. That's all from my side. Thank you for your attention.